Hello everyone, so in this video, let us now go through a shift in whatever we are learning till now. We have gone through a lot of different concepts in Go concurrency. We had started with channels, Go routine itself, now different sync packages, and what is the offering such as wait group and mutex. Then we've also moved down to select. That will help you to select the one channel that is non-blocking and take that forward. And multiple more things we have discussed throughout this series up till now that actually forms up the basic building block that we actually have to learn to go through the further videos in this Go concurrency playlist. Now, what we have seen till now is that these building blocks are very good and necessary, but they actually themselves don't give you the power to solve wide range of problems. So, whenever there is a pattern in these wide range of problems, these are defined under concurrency patterns. Okay, we have talked about design patterns, we have seen design patterns, and then there are concurrency patterns. Okay, how we can use these building blocks to solve bigger problems. Okay, and that we're going to discuss in the further part of this series. If you have more recommendation, put that in the comment box of this particular video. But this is just an overview what we're going to discuss in the later part of this series, and then we'll build upon more on that, but I'll just give you a glimpse of what we're going to discuss in the later half of this series. So let us first understand why concurrency matters in Go. So concurrency is the ability to execute multiple tasks independently, making most of the available resources. We have a finite amount of resources that we have, you already know that. So we actually want to perform a lot of different tasks because we have multiple more cores now. So that is where concurrency plays into picture, and all of them, if they are independent, can be performed as different Go routines. So Go makes concurrency straightforward with Go routines and channels, allowing us to write concurrent programs that are both powerful and readable. That is the overall idea that we actually have to think that why Go routines is altogether important. We have already learned about Go routines and channels in the previous section. If you haven't checked out, I highly recommend you to first check out all those previous videos in this series. And we will have gone through all of them. Now, in this section and moving forward, we will explore why concurrency matters in Go and how it is useful to write better programs. How we can write better programs using all those pieces that we have learned. And we will implement that using different concurrency patterns. Now, what all are concurrency patterns? Let us give you a small definition about that, and then we'll talk about what all these patterns are, and we'll go through one by one in every video all these concurrency patterns so that we can deep dive into every pattern, how we'll implement it, what problem it solves, all the code part and everything. Now, let us talk about why concurrency pattern is altogether important. Concurrency in all is just that multiple tasks we have which are independent can run concurrently, and then we can merge together or like use out information for one, talk to another, and so on. Now there are certain problems which you have seen in industry wide while solving problems which occurs repeatedly. Okay, so all those problems which occurs repeatedly, it has been classified into different patterns because we have seen this pattern like occurring multiple times. So that is why those concurrency problems has been categorized into different concurrency patterns, and those can be solved using these major problems. Like these are major categories which we can use to solve such type of problem. Some are fan in, fan out type of patterns. Some is worker pool, error handling patterns, pipeline patterns, publisher and subscriber patterns, generator patterns, rate limiting patterns. There is also outboxer pattern, context-based cancellation pattern. So these are the major patterns which I actually able to find out. There might be multiple more, but these are the major ones which, if you understood these patterns, then it is highly recommendable that that you have got a very good gist of concurrency patterns. We have separate videos for all of them. I'll just give you one small thing is that what is fan in and fan out? Let's take one example for this. So fan in means that you have multiple routines that is fanning out the work. And fan in means that other one is pulling out. Okay, multiple routines are doing some certain work and they're pushing to some sort of a channel, you can say. and other one are pulling out of it. Okay. Similar is worker pool. We have created a pool of go routines that is waiting upon certain channel or a certain queue. Okay, there are a different type of workers, and any one of the worker pool is our different go routines. Anyone which get the task from a particular queue will pick it up and solve it out. Okay, so all of them requires only those things that we have learned: channels, wait groups, or you can say these mutexes, all of those switches, uh, the switches or select statements. All of those are actually the building blocks of all these concurrency patterns. But where these concurrency patterns are required, where they are, like why they actually required, all of that will be in separate videos. But those are the ones which we will going to discuss in the later half of this series. So if you still have any doubts, or if you have some recommendation of what more videos I can make, put that in the description box for your video. I will see you in the next one. Like you coding, and bye.